and welcome everyone. Welcome to my YouTube channel, and I am starting this Cisco ASA training on my YouTube channel. This is my first video on the Cisco ASA training. So we will have a series of lectures or videos for this ASA. So please be patient and continue stepwise, because this will build up after every video. So you need to go through the basics to understand the advanced topics of ASA. So this video will be just an overview of the ASA, and in the next consecutive videos we will be starting the labs as well. So I'll be using EVNG as my lab. To demonstrate the lab, you can use Cisco Packet Tracer or even use GNS3, right? Or if you're good with the workstation, VMware workstation, you can use that as well. You have Cisco ASA-V virtual machines, and you can use them. So coming back to this video, right? So what will be the agenda of this video? So I'll be just going through the ASA overview, and then just the history, brief history, how ASA has evolved from last 2 decades or 3 decades. So let's start with the history. So what is a Cisco ASA? Basically, Cisco ASA is a hardware firewall from nowadays virtual as well. They have the Cisco ASA-V, but they usually started this with the hardware appliance. So this is a firewall from Cisco, network firewall from Cisco. Okay, but before that, just to recap, what is a firewall basically? What is a firewall? Most of you would know firewall, but I just want to give you a brief definition, right? So what is a firewall? Firewall can be hardware or software, right? Or software, and it governs actually the or you can say controls, right? It controls the traffic flow inbound and outbound through your organization, right? So that is the definition of basic definition, not the complete definition, but this is what you can understand. So it governs or controls the traffic flow of inbound and outbound of your organization, right? And firewalls, as I said, can be hardware and software. So this ASA is both. So you have ASA-V, which is a virtual machine. This is just a software, right? You don't, and then you have these appliances, Cisco 5505 and 5520, 5540, like that. You have the boxes. So those are the hardware appliances, right? So that was a brief. You guys can have multiple definition for the firewall, but let's continue to the history. So basically, Cisco had their first firewall, which was known as PIX, Packet Internet Exchange, right? This was again, predecessor of ASA, but the limitation that it had was it used to do the controlling of through traffic, whatever. But the capability where it lacked was it used to do the side-to-side VPNs, IPsec and L2TP, PPTP, and also the where it lacked was the SSL VPNs, right? So SSL VPNs, it was not able to do the clientless or the client-based VPNs. So what are those? So you even call them remote access, right? Remote access VPNs, and client-based is nothing but using AnyConnect. Or you have, you have in parallel to, you have the global protect, right? So that is the remote client based, and client-less is the web based VPN. So this Cisco PICs lacked these features. Okay, so what Cisco did was, at that time there was another company by the name of Altiga, and they used to produce these VPN concentrators. Okay, so they used to produce these VPN concentrators which were doing the VPN part, I mean, excellently, whether it be the IPsec side-to-side VPNs or the remote access VPNs, right? They used to do the SSL VPNs based on, you can say, the client or clientless. Okay, client or clientless, both. So what Cisco did is they acquired this Altica VPN concentrator company, and this was in early 2000. Okay, they mixed these two boxes, so they had their own PICs, right? And then the VPN concentrator box, VPN box, and this was called as the ASA, right? So this was the generation of ASA. Before producing their own ASA box, they used to sell this solution separately. So they used to sell the PICs and the VPN box as a solution. Okay, so you have these two hardware separately. But later on, what they did is they combined these two, and where the ASA evolved. Okay, and that is how we know the ASA box as of now. So that was a brief history from the ASA point of view. So ASA can be so just basically think about this. What is the difference between a router and a firewall? Basically, a firewall can be a router as well. Yeah. So firewall. Okay. This can do routing as well. They can run BGP. They can run dynamic protocols, right? OSPF, everything. They can run static routes. They can run static routes as well. So firewalls can do the routing job as well, right? But the difference is where the flow comes, right? So just think about it. When you have a router, the default behavior of a router is, so you have a router like this. Sorry for the drawing. So this is a router, so just think about it. And then you have two interfaces of the router, right? And this side you say like 10.1.1.1 is the IP address. This is not working. Anyway, give me a second, guys. Okay, so this is the IP address of the client, say, and this interface should have, say, 10, and like this is, yeah, this side is 10, and this is, say, 11.11.11.1 for the client. So what happens is this router will have a routing table saying that this network, right, 10.1.1.1.0/24 is on my, say, this E00, and this is E01. So this is on E00, and likewise it will say 11.11.11.0/24 lies on E01. So this is the routing table that the router builds, right? It keeps the information of the networks that it knows through the interfaces, and every interface will have a different subnet. Likewise is the case with the Cisco ASA. So what happens with respect to a router when this 10.1.1.1 tries to reach the 11.1.1.1? So what happens is the traffic reaches here, and the router will check the routing table, and if it knows the destination, it will forward it, right? So that is the behavior of router. But with respect to ASA will block this traffic until and unless there is an explicit rule that says to allow it. Okay, but there is certain limitations to that, but we will come to know about it. But in general, just think that ASA by default will not allow this. traffic to go through, depending on the type of traffic, right? If let's say this is an ICMP ping, so this will be blocked. Okay, so that is the thing, and let's see what all components do you have in Cisco ASA. So basically, when you initialize a router, right, what components do you need for the router? Router needs okay, on this interface, say E00, you go to the interface and you say IP add, and then an IP address 192.168.1.100, and then you specify the mask 255.255.255.0, right? So that is how we do it, and then you say no shut, correct? But with respect to the firewall, there are certain other parameters that are very important when initializing an interface on the firewall. So let's think that this is E0 of the firewall, and then you have, so you will go to the interface and you will obviously say IP address and something, some IP address, right, 192.168.1.100, and you can just press enter here. Okay, that is again a plus point of firewall. I'll tell it in detail, but apart from that, obviously you say no shut. But apart from that, you need two other parameters. One is the name if parameter, and then the security level. So these two extra parameters are very important. Name if is important because you name that interface, and later on when you apply an ACL or call that interface in a NATing policy, you have to call it by the name and not by the interface number, right? Not E0 or E1 or gigabit 0. It should be the name. So for example, if I specify this as an inside interface, so I have to say apply that say I'm applying an ACL, I will say on the inside interface, not on the E0. So that is very important. And next is the security level that you define. So the range is from 0 to 100, and this security level is plays a very important role in the default traffic flow behavior of the firewall, default behavior. Okay, we will go through it once we start the labs. I will explain to you how it affects it. But so you can assign from 0 to 100, and 0 is the most trusted one. So basically you will assign it to the inside interface, 100, okay, and 0 is 100 is the most trusted one. I don't know, I said 0 or 100, but 100 is the most trusted one, and 0 is the least trusted interface. So this will basically be your internet. Sorry for the, I don't know why my pen is not working. Okay, so this is the 0 is the internet always, okay, and then you have, say, on the DMs you will put some number which is between 0 to 100, not 0, not 100, right? So that is how it is. And there is one more thing when you specify the name if. Okay, when you specify the name if as, okay, let me take the text. Let me clear this. Okay, when you specify the name if, okay, as 100, by default what happens, the interface will take the security level as 100. Doesn't matter if it's capital I inside, or if it's small inside, or if it's mixed case I, N, S, I, D, E, something like that. It doesn't matter. It will give that interface the security level of 100. Okay, it is not case sensitive, but it preserves the case in certain matters. For example, crypto maps, it is case sensitive, so you need in that sense when you're using crypto maps, you have to have the particular case of the name. Okay, so that is just one condition. Apart from that, I mean, it doesn't. It is not a case sensitive thing. Okay, so what if you specify any other name? So any other name, name apart from inside is assigned a value of 0, and then you have to go and assign the security level of that interface. Okay, so that is the story of security level, and it controls the default traffic flow. We will see how it does. Okay, so whenever you are going to configure a firewall, you have two additional parameters. That's what I said. The first one is what? The nameif, which is used to call the interface in other configurations, and then you have the nameif, right? Sorry, security level, which will control the default traffic flow. So the most trusted interface will get the higher this value, and the least will get the least trusted will get the least value. And also the thing is that, okay, let me just clear this. Okay, give me a second. Yeah, so let's move on to the next slide. Okay, so this is the firewalls, right? The firewalls can be in two modes: routed and transparent. Routed, this is the default mode when an ASA initializes. This is the default mode for ASA, so it will be in L3 mode, and you can use it as a router. You can have IP addresses assigned to an interface. You can have routing capabilities, and there is another mode, that is the transparent mode, which is basically the L2 mode. No, wait a second, guys. Let me take my pen again. Okay, this is the L2 mode, and in this case, the firewall will not be doing a routing. Okay, and we will see the design perspective as well, where we will use the L2 and L3 like that. But just keep in mind, L2 can have two interfaces in the same subnet, right? This is the point, and in L3 each interface is in different subnet. Okay, so that is the transparent, and we will do the deployment of transparent mode as well, and you will clearly understand what is the difference. So that is that, and let's move on to the next slide. Let's see what is the next slide that we have. Okay, that's what I was saying. The ASA firewall is an L3 router by default. It has all the routing functionalities that a normal router would have. It can run a RIP, it can run EIGRP, OSPF, and BGP routing. Apart from static routes, it can do default route. The difference between regular router and an ASA is that the router follows all traffic by default, whereas the ASA will allow traffic based on certain policies, which will be discussed in this video. So that's what I said. So you have the default behavior of the router is that it will by default allow any traffic to a destination that it knows, but in firewall it is not the case, and you need a separate rule to allow that traffic. Besides assigning the IP address to an interface, the ASA requires two additional parameters on the interface, and that will control the traffic. So that is what I said to you, right? So you need the nameif. Commonly inside VMs or outside, the nameif of the interface is not case sensitive. So we are just going through the it's kind of recap, right? The name of the interface is not case sensitive. Although it is not case sensitive, it does preserve the case, as I said in the case of crypto map, right? And it is a required parameter. Obviously, it is a required parameter. All command references the interface using the name, not the physical ID. That is what I said when I was telling this to you, right? Okay, then you have the security level. It is a number between 0 to 100. It controls the default traffic flow through the firewall. Okay, there is something called to and through. So this security level will control the through traffic, not the to traffic. Through traffic is like the management traffic. Okay, okay. So it is the control plane. Anyways, then you have the so this security level is going to govern the through traffic. Just keep in mind, when you configure brand interface with a name, it sets the security level automatically to 0, except if the name is inside. That's what I said in the previous explanation. Define how trusted the interface. So this security level will define how trusted the interface is, and by default the higher the traffic coming from the high security level and going to the low security level will be allowed. We will go through this definition, I mean the sentence that I said, and I will explain it to you in the coming videos. IP address, you have to configure it just like you would on a router, but the plus point here is you okay, let me just take the pen. So in you need to keep in mind in ASA you have an option. You have an option. So the color is wrong. Let me take this. You have an option. For example, if you go in an interface and say IP address something like IP address interface, so it's interface E00, and you go in the next line say IP add 10.0.0.24, and then you hit enter. So this will be taken, while as in the router you have to specify the subnet mask, but here it will be taken, but the default subnet mask of the class will be taken, which will be /8, right? So you have that option. If you are configuring a class full subnet IP address, then you can hit enter. If it's a class less, then you have to specify the subnet mask, and Cisco doesn't understand the wildcard mask, so you will see subnet mask everywhere, even in case of ACLs and in case of your OSPF configuration, right? So that is the that is an information that I want to provide you. So next is you do the no shut command, right, after the configurations on the interface. So yeah, so let me just click on this. My I don't know, this pen is hanging a lot. So okay, so this is the ASA default traffic flow. We will go through this in the next video. So this is it for the video, guys, and stay connected to my channel and follow my YouTube channel, subscribe to my YouTube channel. I'll be adding more videos to this series so that you can understand the whole concept of ASA clearly. Okay, for now it's a bye bye from me. See you in my next video. Thank you.